To save some time, I'll just copy this and I will make the changes. So we are not going to return it because we're pushing this element now. So first of all, I will check that while pushing, we have to ensure that the stack size is not is already not at the capacity level. So it means that it should not be at capacity. If it has capacity, it means that our full condition should be awaiting. See, similar to that, what we have done in pop. When the stack size is 0, it means that the stack is already empty now, and all the threads has to wait for the not empty condition. Similarly, if the size is full, it means that size is equal to the capacity. It means that the stack is already full to its capacity, and that's why this condition of not full is not true anymore. So it has all the threads waiting on this condition has to await here. Okay, and after this, let's me change this. So I will just stack dot push item, and then I will take this out from here. We don't need to put in finally block, and I will put stack not empty condition as signal all because we have already pushed one element now. Okay. Now guys, let's revise it one more time. So in the pop, we are actually maintaining two conditions. So stack not empty condition and stack not full condition, right? This will happen when the stack is not empty. And this stack not full condition is that, as the name says, that when the stack is not full. Now we have to synchronize between this pop and push methods. So what we are doing is that in the first condition, we are checking in the pop that whether the stack is empty or not. If the stack is empty here, it means that not empty condition is not correct and the threads has to wait for it. So that's why we have to wait here. We have called this await signal. So whatever threads are waiting for this condition, that is not going to be true unless we got anything pushed here. Now suppose there is one pop thread and it has reached to this point when the stack is actually empty, and that thread is waiting on this condition because it's not empty yet. So, and now another thread comes and it uses this push, and now it checks that the size is already 0, so it will not go inside this loop, and then it will push this item here. When the item is pushed here, it means that there's at least one element present in the stack now, and that's why it actually, so not empty condition is not true anymore. It's actually not empty. So it means that it will signal all the threads which are waiting, which indicates that the stack has got at least one element now because it has already pushed it. Now the thread which was waiting here, it will come out, it will get notified because of the signal all method here. It means that it will come out of this while loop, and then it will pop the element which was pushed by here. So similarly, condition we can check the vice versa when the stack is like full. Suppose the capacity of the stack was 5, and it has already hit the capacity now. We have got 5 elements in the stack already, and there's one thread which is coming to push a new item, the 6th item here. It will come inside it. It will lock this object, and then it will check that the capacity, the stack is already 5, and it will go inside this while loop. And because the stack is already full now, so the not full condition is not true. So it has to await it. So that's why await signal is called. So that pushing thread has to wait here now. Now suppose there was another thread for like a consumer thread which comes here pop, and then it will come here. It will see that the stack of size is actually 5. It's not 0. So it will not go inside this loop, and then it will return the top element. Once it returns the top element, because we have put in the finally block that we have to signal all. Because now we have already popped the element, now the stack size would be 4 now. Earlier it was 5. The 5th element has been popped out and returned from here. And finally block would be running now, and it will signal this condition that stack not full condition is not full anymore. So it's and now it will be signaling all the threads. So now once this thread is signaled here, the thread which was waiting to push here now, it will get notified, and now it will push this item here now. The 5th item would be on the top of the stack, and then the stop not empty condition would be signaled all. So it means that whenever for the vice versa, that is now not empty anymore, and the stack is already have got one pushed item. So this was all about this pop and push. A little bit tricky, but if you go through the use cases as we just discussed, then it would be easier to understand. So in other words, we have to take care of like two conditions only: when the stack is not empty and when the stack is not full. And then we have to coordinate the locks and the conditions accordingly. So now we are done for push pop, and let's implement for peak as well. The peak would be very much similar to pop, except that we are not going to actually remove the top and move it to the next element. We just, so there's already a stack.peak method here, so I will just use that. It would be exactly same as pop, so I'll just copy this first and then put it here. And here I just need to call peak. Okay, that's the only change. The rest, all the conditions would be exactly same as pop. So we have implemented this push, pop, and peak. I hope you guys would have understand all these conditions and how we implemented it. Now let's write some test cases.